Hello out there, and a warm welcome to our last morning session within this world of electrification and automation. I am Michaela Münikes and will gladly guide you through this presentation. Our next speaker had been planned to be our dear colleague Bruno Opic, but he cannot join us today in the studio. Bruno, get well soon. So I'm very glad that Oliver Schrödel jumped in and will take over Bruno's session with information on how to master distribution grid diversification by IoT. Please feel free to post your questions at any time during the presentation. Oliver will try to answer them live at the end of the presentation. We'll see how many of the originally planned for Bruno's questions he can take, but just address them. We will handle the answering process. And please make intensive use of this possibility to directly address our experts. If Oliver cannot answer the question, we will find an answer and answer you via mail. We are here for you and for your questions. And one of the questions is rather often, do you record the session? And yes, we do. And now, Oliver, let's focus on how to improve reliability and operational costs. And let's learn how to get more data with IoT. And therefore, Oliver, the stage is yours.
Thanks a lot. Good morning. Hello, my name is Oliver Schrödel. I'm a senior key expert for distribution automation system and application. Today, I will show you how can master distribution grid diversification with IoT. This talk is about the challenges we face in the distribution grid and therefore resulting the demand of more sensor and analytics. But new measurements and alarms in the way we are used to will solve the problem or will not solve the problem we are having in now. A novel combination of new data acquisition combined with cloud-based analytics is pioneering the way forward. New load and increasing volatile renewable infeeds are pushing diversification of distribution grids, while parts of the grid are in idle, others are utilized on the limits. How we can handle that? Furthermore, the pressure on the existing infrastructure is increasing fast and in different directions. Due to the consumer and political demand, the energy system shall become greener and faster as possible. It is expected that distributed renewable energy resources will increase 7 times until 2030. This will cause a demand of handling so specific areas, e.g. with microgrids, which will result in a growth of these applications by 19%. At the same time, new volatile loads and new players will change the energy system. We can see those changes already, because since 1965, renewables yearly growth and reached 15.5% by 2019. Also, the fleet of electrical cars reached 7.2 million in the same year. And finally, energy storages are deployed at a growth rate of 24%. The development of power grid capacity by old means will not be keep pace with this diversification of the infeed, loads and new business demands due to the market players. This and the immense cost of grid expansions adapt those needs results in an alternative strategy making power grid more energy intelligent. This is new. Now, we have a look into the power transmission grid. There is the state of the art, which means nearly 100% is equipped with sensors and actors. assets with high value and impact of failures on a large areas are justifying the necessary invest for monitoring and control. It is even well-proven concept and application. But the distribution grids are not equipped and monitored to that extent. Only 10% of the secondary substation have either monitoring and control for medium voltage distribution. Low voltage distribution grid is totally blind, and so we have a new world on this area. So that means we have to connect more sensors to this level. So how are these kind of challenges, and what can be the answer? A high number of assets can be connected, and we must have a technology which must scale on low cost. And we need plug-and-play IoT solution for this scaling, like the plug-and-play functionality you know from your printer, where you connect a printer to your PC and automatically all drivers be connected. So how we can do this in future? So one way forward is the CCAM diagnostic suite of the SICAM Navigator. And what are the technical principles for this? So we need a solution which is easy to be connected inside the grid. And on the left-hand side, we see the communication architecture on the station levels. So where we have different devices connected to the field level, and via our SICAM A8000, this kind of data is later on brought to the cloud. So that means we have now new elements in the grid, like the new fuses, the 4COM, which 3NA COM, honestly, which can be connected to our SICAM A8000 and provide the data to the MindSphere. And with no touch and zero-touch onboarding and no engineering in the cloud, we can have a close overview on the SICAM Navigator. That is the technical principle for the level of the secondary stations monitoring. But we have not only have the SICAM Navigator, we have also the SIPROTEC dashboard, which has a similar need. So we like to have the data which is selected in a primary substation and will be also shipped to the cloud. So that means in this level we have a communication via IEC6150, and by this kind of communication path with the IEC6150 we can connect our grid edge device. Our grid edge device can easily connect to the MindSphere cloud and will bring all data via the IoT gateway, you see here, the SICAM edge device via MindSphere, and have then also, with a zero onboarding, no engineering efforts, the overview over the protection relays in the cloud. And just as it IoT, so no changes in the existing relays. So is it not only just old wine in new bottles? So how we can use now these kind of new functionality of IoT for these kind of applications. And I will give you some new and old challenges in the distribution grid on this. So what are the main drivers for this IoT information and applications in total? So for all, we have long fault and localization times by cable outages and all these kind of topics. Then we have equipment fails, where we have a breakdown from overhead lines or from transformers. And the next topic is the expensive grid expansion, cause of the new needs of the new loads, like the EV vehicles or the electronic vehicles and all these topics here. So that comes in line with, on the other hand side, of the renewable in-feed. And new loads again with heat pumps and electronic vehicles. So that means we have a lot of new challenges to our old infrastructure, which we can deal and tackle with IoT information. So what is the role of IoT in this kind of cloud-based application? And here's a very nice sample, which brings it a little bit lively together. So, because we have on the one hand side the SCADA application, and on the other side the IoT application. And what are the split between IoT and SCADA application? And SCADA is still necessary for operation. So it's like our steering wheel where we can operate everything finely and nice and tune the total system in a total overview. But we have also the IoT, the simplified operation and maintenance, which is a kind of guidance on this kind of application, like these kind of new applications which are downloaded to their cars, for example, that guide you to the next parking lot and so on. So that's a driver assistance topic which helps you to fault and evaluate the system. So, in a nutshell, analytics for power grids helps to identify the grid constraints. It helps you also to handle grid disproportion, and it identifying component at risks. So not even when the risk appears, so even in front. So it helps you to have the next level of maintenance and supervision of your grid. But what's next? What are the continuous DevOps and AI-based analytics? And I like to give you here 4 samples. And it's also quite nice because you see here also with these kind of data which we gather from the field level, from the substation level, we can do also then more applications, and we can also run these applications in a next level. So even we can roll out this application quite fast and also adapt the application if we have new insights. For example, for grid load evaluation, which you see on the left-hand side. Or we have root cause recognition, where we can also adapt different scenarios and finding finally the root cause of the problem. And also declare behavior to see about when change of the behavior was happening, for example, and what are the extent of these kind of change of behavior? Is it inside the limits, or is it sometimes what we need to react on? And also some kind of fault propagation to figure out, okay, where we have the next faults, what are the next maintenance issues which we need to do and to handle. Finally, I like to come to a conclusion of the whole conclusion and summary of our session today, and give you some insights what our conclusion on this is. So because we have built up a nice grid diagnostic suite, which helps you to navigate through the system, through the medium voltage system and even to the low voltage system. And it helps you to integrate large-scale renewable integration and swarm loads like e-cars. Thanks to our cloud-based application of data analytics through medium voltage and low voltage distribution area, we can unite complex fault situations, clever handle grid constraints up front, and turns also our grid behavior in a carbon dioxide reduction. So that is a little bit, in a nutshell, our ideas, what we have to bring together in our grid diagnostic suite, also to come to the next level of IoT applications. That was a summary of our small insights of this session, and thanks a lot, and I'd like to hand back to Michaela.
Oliver, thank you for jumping in on that. That was brilliant. And I already have some questions, but we have more time for you.
Thanks.
So just make use of it and just put in your questions in the question answer tool. The first question is one I will take the answer. It is,
good.
Will you provide a certification for the summit? This is not a training, this is not a webinar like this, so it's information that we send out to you, but not with a certification here. We have different formats. Sometimes we do a training, we do dedicated webinars, and then you can receive a certification. This time it's up to you if you find it useful, hopefully, and put it somewhere in your agenda. And then it's an interesting question for the topic that we have right here, what I see there. How does a vacuum circuit breaker work in medium voltage distribution and protection? I mean, it could eventually be that you know something around it, but that's definitely not our area of expertise. But I have an idea for you. I just see the initials. It's AO. I have an idea for you because we still have the exhibition open. And within this exhibition in the world of electrification and automation, you have the possibility to not only visit the booth for the medium voltage colleagues there, but you also have the chance to push this button and get in contact directly with our experts. There's the possibility to join a Teams room, and then you will be guided to 101 meetings with our experts. So no problem that the question is a little bit, what do we do with it here? We are no vacuum circuit breaker experts. I've seen one on one of the exhibitions, but that doesn't help you with explaining that. Ask the experts there. Then we have a question from somebody who knows, I think, a lot about our technology, because the question is how to integrate the ADMS system with DERMS in a smart grid scenario in IoT perspective. That's everything in it, because
that's good. So
ADMS is Advanced Distribution Management System, for all who don't know that. And then it's DERMS is something you can explain. It's Distributed Energy Resource Management System, something.
Correct.
Okay, and now you go with the IoT perspective.
Good, that's perfect. So already we started to sort the things out. So we have the ADMS system, the Advanced Distribution Management System, which helps us to have a closer look and to optimize our distribution grid for the distribution grid operator, for example. Then we have the DERM system, where we have a specific view on the distributed energy resources, honestly. So that are like the nice picture which we saw in the slide deck with this kind of steering wheel, where somebody is really actively to drive the grid, to drive his car to the right side. And this is something like a must. So that is not an option which you can put it to the cloud or to cloud IoT services. But we have a topic here, which is nicely here, which guides us a little bit to this kind of DMS and ADMS and DERMS topic. Because when we see about, okay, how good is our equipment in the field level? So what are the balances which we are already reached, for example, or what are the actual loading situation on the different areas, for example, and what kind of equipment we have? That is a topic which we can share and match in the IoT perspective. And then we have both. We have on the one side this kind of really steering and driving the renewable in-feeds, for example, to reduce the power in-feed, for example, or to shift loads from one hand side to the other hand side, for example, to do these kind of active load management inside the grid. And we have on the other hand side the perspective, okay, how much of these kind of energy resources we are allowing to build inside the grid, that we are later be able to manage it in the ADMS system without getting it out of service. So that is a little bit the topic. So like we have both worlds. One is this kind of steering wheel, on the other is like the navigation. How is the next step? What should be done next?
Thank you. And there's even one more question. Let's see if we can take that. Could you please describe the compatibility of the IEC61850-95 and your IoT technologies?
Oops. Honestly, I can't tell you much in detail on this, honestly, because I'm not an expert in IEC 61850 and the new version of communication in here. The topic is mainly that we use a standardized protocol, which is the MQTT protocol, for example, or our MindSphere connector. And this is something which is unique and can be used by everybody. And that is also why we don't use the IEC 61850 standard. So we use an open cloud-based standard, because honestly, we will have also some devices which will not have an IEC 61850 connection because it's still too expensive. So that means, for example, you see this kind of nice transformer substation where we have very, let me say, budget device inside. And that is the reason why we need also some protocols which can be also supported by these kind of devices which we have in the substation on the low voltage level. And that is the reason why we use these kind of MindSphere connector or the MQTT protocol. So that is a little bit the topic which from our perspective is from a greater perspective for a cloud-based application, more useful.
Thank you. Thanks for the comprehensive answer. Thanks for the former question about the ADMS system. Your answer was appreciated by the nice participant from Saudi Electric. Thanks for that. That was interesting. I do have no more questions in the line right now. Thanks for the questions so far. Thank you for joining us right here. If questions come to your mind later, Oliver is on LinkedIn, Bruno is on LinkedIn, get in contact with them there. Or take our now conference session break. In about 2.5 hours, we will continue. But you can take the time and scroll through the exhibition and meet the experts there. That's why we are here, taking your questions and answering as many of them as possible. So for now, thank you, Oliver, once again for jumping in. Thanks for even being able to answer some of the questions. Respect for that. Yeah, if we have experts in the studio, they normally know a little bit more than they are just here for the presentation. So thanks a lot for that. Thanks for joining us. I'm looking forward to see you in our afternoon session block. The first one will be in about 2.5 minutes and a little bit more, where Klaus Wagner and Kerem Bayram will talk about measures to reduce the effects of arc faults in air-isolated medium voltage switchgear. So I'm now looking forward to see you there again. I thank you for the time you already spent with us, and take care and see you soon.